So we've got a cone and a sphere. We are told that k times the volume of the cone is equal to the volume of the sphere. Show that the total surface area of the cone can be written in this form. Okay, so k times the volume of the cone, which is a third pi r squared h, is equal to the volume of the cone. Nope, sphere. I'm just looking at how they want my answer. It's got no h's in it. So I'm assuming we're going to be making h a subject here from this equation. So let's start out by dividing both sides by pi, multiplying both sides by 3. A third times 3 is 1, which gives us k r squared h on the left hand side. 4 over 3 times 3 is 4, 4r cubed. Let's divide by r squared. So h is equal to 4 over k r. So we can rewrite h here as 4 over k r. Total surface area of a cone is pi r squared for the circle plus pi r l, where L is the slant height here. And again, in our answer, there is no L. I'm going to find L in terms of H and R using Pythagoras. H squared plus R squared equals L squared. H is 4 over K R. 4 over KR times 4 over KR is 16R squared over K squared. Or you might have it as 16 over K squared with the R squared next to it. It just means the same thing. I want to be mindful of how their answer looks here as I'm working with making L the subject. What I think I'll do is I'll add these fractions. I'll add 16r squared over k squared plus r squared. I need a common denominator of k squared. To add them, I need to make this into an equivalent fraction. So at the moment it's 1 as a denominator. I can leave 16r squared, it's already over k squared. But let me just change the colour of the pen a second. 1 times k squared is k squared, so I need to times my numerator by k squared, which gives us 16r squared plus r squared k squared, or k squared r squared, all over k squared. I'm going to factorise at the top here, again being mindful you've got your k squared separately, so I'm going to factorise it by taking r squared out. I'll just do that over here. And then I need to square root everything to make L the subject. So what can we square root here? We can square root the denominator of k squared. We can square root the r squared. But because the 16 is involved in a plus k squared, I have to leave that under the square root. Okay, so now I can replace the L for R times root 16 plus k squared all over k. Okay, looking a little bit more like this now. So pi times r, I'm just going to read that as pi times r squared. They factorised by taking out pi r squared, which gives us this 1 plus root 16 plus k squared all over k. If I add those terms in the bracket, so 1 is the same as 1 over 1. Want my common denominator to be k, so I'm going to times k, which gives us pi r squared. 1 times k is k. Which means that a is, well, if you just rearrange this to k squared plus 16, a is equal to 16.